Hello, everyone. So I wanted to cover quantum numbers in case you forgot. So your quiz will consist of a couple of these questions. And for this example, you're asked to draw on the full orbital diagram for silver. So the first thing I would do is figure out whether or not silver is one of your special rules. And it is. And he actually didn't cover some of them, and there's more out there. So your acronym that I created is Crying Monkeys, cause silver's gold. So this will be chromium, MO, don't ask me what it is, copper, silver, and then gold. So memorize this acronym because there's a lot more out there that he did not cover. So after you figure out whether or not it's a special rule, you're then going to do the electron configuration. Um, Pretty much what a special rule is, because I forgot to mention, is that in an energy diagram, your D is actually very close to your S orbital, and that your S orbital would actually rather give up its electron to the D in order to satisfy the atom, in order for it to be more stable. That's just the tendency of these special atoms, and you have to know that. So, it's going to give up its electron and give it to the D. So if it was once 2, it becomes 1. And then this was 9, it became 10 electrons in the D. So after you do that, you're then going to start drawing in your boxes. And I want you to draw these symbols above the box. So the middle box will always be 0, and then you're going to go from left to right. So it's -1, +1. Okay? Middle box, 0, -1, -2, +1, +2. Okay? Those are the symbols. They will help you. Now, for this question, give the 4 quantum numbers. So I defined what those quantum numbers are. He will not. So you not only have to know what they are, you have to know this in its very specific order. Okay, they cannot be out of order. It has to be your N, your L, your emps of L, and your emps of S. So I defined what those mean, but what do they mean to you? So, um, first off, your special rule is it's defined as the last electron drawn. So you know how the last thing you did was that the S electron was given to the D orbital electron, right? So wouldn't it be this guy, the last thing you did? For special rules, it will always be this guy, okay? But in any other case, the last electron drawn would be this one. Okay, so that's for any other atom. It's just the last electron you drew. I want you to circle it, and then you do the quantum number based off that electron at that position in time. Okay, so pretty much the first 2 quantum numbers will be associated with the bottom of the box, and then the last 2 quantum numbers is the top thing in the box, or the symbol you did. Okay, so your N is considered your period number. So you'll refer to the periodic table, right? Here's silver. It's in period number 5. So that's the quantum number, n is equal to 5, or it's just right here. It tells you. Your L is considered your shape, but to you, it's what block you're in, okay? Or to help you memorize this, there's an L in block, okay? So it's how to just help you know what the heck L even means. It's just block, what block you're in. What do I mean by block? So this is your S block, your P block, your D block, and then here's your F block. Okay, so if this was an energy diagram, your S is at the bottom, P, D, and then F. So you're going to start from 0. Your S number associated with it is 0, and then you go 1, 2, 3. Boom, just that simple. Okay? So L, right? There's an L in block, and then you just start from 0, whatever it is. Okay? So 5 is associated with N. Your S is associated with L. Start from 0. S being 0, P 1, D 2, F 3. Okay? The last two quantum numbers is the symbol you drew. So pretty much your M sub L is the actual symbol. So it's just symbol 0. So then the answer is 0. And then your spin, there's a couple things you have to know about spin, okay? So first of all, if there's only one electron in the box, it could be both, right? It could spin either way. There's nothing in there. So it can either spin up or it can spin down. You draw it spinning up, but technically it could be both. However, if there's two electrons in there and the last electron you circled was this guy, it could strictly be negative 1/2. It cannot be positive, it cannot be both or positive because it's obviously pointing down. So if you circled this electron and you wrote both positive and negative 1/2, you're considered wrong. Okay? So so just to recap, if there's only one electron, it's both. Um, and then obviously whatever you circled, whatever direction it's pointing, it's positive or negative. Okay? Not both. So those are the quantum numbers. Now, for these questions, you're simply just going to count. So how many electrons are in n is equal to 4? So you're going to find all the times you labeled 4. You're going to count up the electrons in the boxes. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18. Cool. How many electrons are in M sub L equal to 0? So remember, M is symbol. Okay, so just associate M, every time you see M, as the symbol you drew. So if it has a symbol of a 0, count up those electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, here's 19. 1 electron. How many electrons are in M sub L equal to negative 2? So look for the symbol you drew above for negative 2. So it's 2, 4. Okay? How many electrons are in L equal to 0? So remember, there's an L in block. So it's the shape of 0, and that's your S block. So there's 2, So I'm looking at the S's. There's 2, 4, 6, 8, 9. Okay. How many electrons are in EMS of L positive 1/2? So positive 1/2 is strictly the up arrows. You're only counting the up arrows. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, it's 24. Now, if it was asking negative 1/2, it would still be 24 because even though this one is pointing up, it's technically both. That could be tricky for some people, okay, and you might get that one wrong. So it's technically a trick question. So be careful with the spin questions. And that's pretty much it. So have at it. Let me know if you have any questions.